Hello, welcome to my channel. We are continuing with partial fraction. This is episode 3. So we are taking the type 3, whereby the denominator, we learned that partial fraction decomposition is based on the type of denominator that the fraction is having. So the third one is saying that when the denominator contains quadratic factor, a quadratic factor that is non-repeating. So you can see this is just one quadratic factor here, non-reducible. We can't reduce this again. If it were to be minus 1, we could have done this into difference of 2 squares. So this will have fall under the first type. But since it's plus, we take it as what? The third type. So the decomposition is going to be that A over the first linear cofactor is x plus 3. So under this, we have bx plus c over the quadratic factor. If it were to be only this factor without this will have been our decomposition. But since it's having a linear, we take the linear aspect. It's having quadratic, there should be x in our numerator and a constant, then we can do that. So we are having a fraction on both sides, so we look for LCM or LCD, which is going to be the same factor. So multiply the left and the right by the LCD will make this to cancel. So I'll be left with only 9x minus 7. So when x plus 3, x squared plus 1, multiply this, x plus 3 will cancel itself. I'll be left with only x squared plus what? 1. Then plus this quadratic will also cancel itself, leaving only bx plus c. So multiply x plus what? 3. So now we have our linear devoid of fraction. So there are two approaches. One is to put a value of x to a particular number to eliminate one of the variable or compare the coefficient. So if I look at this carefully, these two brackets are multiplying, right? So if I make this bracket to become 0, it automatically make this also become 0. So if x is negative 3, negative 3 plus 3 will give us what? 0. So put x equals to negative 3, meaning 9 times negative 3 minus 7, negative 3 all square plus 1, b times negative 3 plus c, negative 3 plus what? 3. I believe I'll get 27 here, but negative. So negative 27 minus 7. This is going to be 9 plus this will be 10. So we have 10 what? 10a. Already we know this is 0. So it cancels everything in there. So you need this to become negative 34 equals to 10a. We need an a. So what do we do? Divide both sides by 10. So a is going to be negative 34 over 10, or negative 2 here, 17, 2 here, what? 5. So by cancelling the a, the b and the c, we have the value of a. Alright, look into this. Can we eliminate a by making x negative? If x is negative, I'll have 2. So no elimination. If x is even 1, I can't eliminate. So it means I can only compare. So I have to rewrite this. 9x minus 7 equals to, open this to get ax squared plus a. I mean a multiplying to open this. This is going to be this multiplying this. Bx times x will give us bx squared. Bx times 3 will give us 3bx. Then c times x will be cx. C times 3 will be 3c. I see x square, so I can group like terms. My 9x minus 7 equals to, if I put these two together with a common factor of x squared, it becomes a plus b x squared. So I'll be left with a factor of x. That also make it 3b plus c. Also have a common factor of what? X. So what is left? Plus a plus 3c. This is a constant. This is a constant. Alright. So we are now going to comparing corresponding coefficient. I'm having x squared here. So I need to go to the left and pick x squared. And it begins with x to the power 1. Meaning the x squared term is 0. So that will be 0 is equals to a plus what? B. We can take that to be our first equation. We are having x term and x term. So we take each coefficient to be 9 equals to 3b plus c, equation 2. I believe you are thinking of equation 3, which is minus 7 equals to a plus what? 3c. That could be the third equation. But since I know a from the first calculation, I know I can find b. And if I find b, I can find c. So let me leave that equation 3 aside. So put a equals to negative 17 over 5 into the first equation. That will be here as negative. So when they cross, it becomes positive. That makes b equal to 17 over 5. Then knowing b, so put b into equation 2, meaning 9 equals to 3 multiplying 17 over 5 plus what? C. 3 and 5 are not common. They don't have common factor. So the 3 have to multiply 17. We know 17 is 10 plus 7. So 10 times 3, 30. Then 3 times what? 7, 27. 30 plus 27 is what? 51. So 9 equals to 51 over 5 plus C. If I like, I move this here, or I multiply by 5, the LCM. So 9 minus 51 over 5 equals what? C. This is having LCM of what? 5. So here we multiply the top by 5, down by 5. Let me use this corner. So I have 45 over 5. 51 over 5 equal to C. I'm only trying to make the first fraction have the same denominator. So 45 over 5 minus 51 over 5, they have the same denominator. So we only take away the numerator. So 45 minus 51 will be negative 6 over 5 equal to C. Meaning the value of A has been known as what? A is negative 17 over 5, B is 17 over 5, and C is negative 6 over what? 5. So we are going back into the original question to replace the A, B, and C with its corresponding value. Meaning, if I replace here with 17 over 5, the 5 will come down as what? Denominator. So 5 minus what? 17. The first one. So for the B and the C, luckily they are all having the same denominator. So it means that if I put 5 here, don't forget if I have 2 plus 3 over 7. I can write this as 2 over 7 plus 3 over 7. If they have 7, they can be separated. So that 5 can also take its position here. Then this will take the 17. Then this will take minus what? 6. So in all, this fraction is going to be negative 17 over 5x plus 3 plus 17x minus 6 over 5x squared plus what? 1. So this is the partial fraction of this resultant fraction. Thank you for watching. I believe you grabbed the concept. The process is a bit long because the board is not lengthy, but I believe the concept is grabbed. Like and share with your learning colleagues. Leave a comment. Let's get interactive. See you in the next episode as we take the fourth type, which involves a quadratic but repeated. Bye-bye.